Hello, welcome to my YouTube channel. I'm Mwalimu David, and I will request you to subscribe, like, and share so that this knowledge can reach to as many people as possible. So today we are going to take a tutorial on open channel flow, which will involve Chezy equation. So the equation read: the velocity of water flowing uniformly in a rectangular flume of base width 600 millimeter is 0.1 meter per second. The depth of flow is 300 millimeter and Chezy constant is 56. Calculate the following. We need to calculate the bottom slope and also the conveyance K of the flume. So here, what we are going to do in first channel problem, you have to sketch to see the outline of the component. So here is our sketch. So this is our sketch of the channel, and we are saying that the channel is 0.6 meter, which is 600 millimeter in base width, and the height or depth of water is 300 millimeter, which is 0.3 millimeter. Now, from the equation, we have been given this value. We have been given velocity as 0.1 meter per second. We have been given Chezy constant C as 56. But we know that to compute velocity, velocity is equivalent to Chezy coefficient multiplied by the square root of bottom slope times hydraulic radius. Now, you know hydraulic radius can only be obtained when you have the weighted perimeter and the area. Now, we'll start by this. We'll start by computing the weighted perimeter. Now, when we talk about weighted perimeter, it means the parts of the channel that are in contact with water. So for this case here, you find like from here, from where the depth of water is, this way, and this way is what we call the weighted perimeter P. So now our weighted perimeter P will be equivalent to B plus 2Y. This is B. Then we have Y and another Y. So it makes it B plus 2Y. We can substitute and say 0.6 plus 2 times 0.3 is equivalent to 1.2 meter. But now area we know that is simply length times maybe height. Or we can say B times Y, which is 0.6 times 0.3, you get 0.18 meter squared. Now, hydraulic radius is the ratio of area divided by weighted perimeter P, which is 0.18 divided by 1.2, you get 0.15 meter. Now, from this formula here, we know that from this formula, we've said this formula here, if we want to make the bottom slope to be the subject, it means first of all, we'll square each component. We end up with V squared is equivalent to C squared times S naught RH. Now, if I make S naught the subject, V squared is here. I divide it by C squared. I divide it by RH. So substituting, I get 0.1 squared divided by 56 squared times 0.15. This will give us 2.13 times 10 power negative 5. Remember, the bottom slope has no units. Why? It's like a gradient. It can be kilometer per kilometer, or say centimeter per centimeter, or meter per meter. So it is unitless because the units will cancel each other. So we'll end up by approximately 0.0002. Now, conveyance K of the flume. Now, remember, we know that shear stress at the bottom of slope of bed of channel, shear stress at the bottom of the channel is equivalent to unit weight of water times hydraulic radius multiplied by the bed slope. Now, normally, remember, shear stress is same as pressure. We know pressure is given by gamma H. And now here, now the reason why our gamma is here, our H we replace by hydraulic radius, but now we are adding bottom slope. Why? Because when we take gamma h, we assume that the bottom or the pressure, like the bottom surface, is horizontal. But our case here, it is at a gradient, it is at a slope. So we have to factor in the slope. So shear stress is given by unit weight of water times hydraulic radius times bed slope, which can also be given as this conveyance K multiplied by velocity squared. Now, if I have to make K the subject, I will say K is unit weight of water times hydraulic radius times bottom slope divided by V squared. Now, unit weight of water, how do you calculate unit weight of water? Unit weight of water is equivalent to density of water multiplied by gravitational field strength. Density of water, normally assume it to be 1000 kilogram per cubic meter. Then the value of G is 9.81. So if I multiply 1000 times 9.81, I end up with 9810, which is the unit weight of water. So I multiply by hydraulic radius 0.15 times slope, which is 0.00002. I divide by V squared, which is 0.1 squared. So I'll end up with the value of K being 2.943. Thank you very much for your attention. See you in the next presentation.